Okay, this is the next section of integration techniques in Calc AB 8.5, the method of partial fractions. This is pretty straightforward, and I think you're going to like it a lot. Pretty useful stuff. Key points. Suppose f of x equals p of x over q of x, so a rational function, such that the degree of p is less than the degree of q. Well, that would be called a proper fraction right there if that's the case. All right. So, proper fractions, we can do all kinds of cool stuff like impartial or partial fractions here. Then we use the method of partial fractions. So, Q. Okay, Q is the divisor right there. So, what we want is Q to be factorable and have distinct factors. So if Q of x equals x minus a sub 1 minus x minus a sub 2, and so on, all the way to x minus a sub n, where the roots a sub j are distinct, then there exists constants a sub 1 through a sub n such that p over q of x equals a sub 1 times divided by my first factor plus a sub 2 divided by my second factor, and so on. So BC students may be tested on partial fractions involving non-repeated linear factors only. I'm going to show you some repeated ones tomorrow maybe. These expressions may appear in the context of the logistic differential equation, section 9.4. The rest of the material in this chapter is optional. So let's have some fun. So this integrand right here is a proper fraction because the degree of p of x is less than the degree of q of x. So let's write this x squared minus 1 in factor form, which is going to be what? X plus 1, x minus 1. And now let's write this as some coefficient over the first factor plus some other coefficient over the second factor. And you can call these whatever you want. I'm going to call these a and b right here. Now, all we do is multiply this equation by the divisor on the left. And look at what we get. So, I'll have a 1. And this is multiply the equation by the distinct factors of q of x. So, 1 equals a times x minus 1 plus b times x plus 1. Now, we're going to solve for a and b. So, this is pretty simple to do too. Let's let x equal a number that's going to cancel one of these terms. See that right there? I could let x equal 1. And what happens if I plug that into that equation? I'm going to get 1 equals a times 1 minus 1 is gone, and I'm left with 2 b's. So b is 1/2. Now let's do the same thing with the x as a negative 1. So this time I'm going to get 1 equals, and that's going to be a negative 2a plus 0. So a is negative 1/2. All right, so let's put this stuff together. And, it doesn't matter the order of the terms or anything. Some people like to start with the positive term. I usually won't do it, but I'll try it here. So I'm going to let my b equal 1/2 right here, and I'm going to bring that out as a coefficient, just like that. And then I've got my dx over x minus 1. And then minus the 1/2. And then we've got our dx over the x plus 1. And now we can anti-differentiate these two and we're done. So, here we go. I've got 1/2 times the natural log of, and we need our absolute value here, absolute value of x minus 1, minus 1/2 times the natural log of absolute value of x plus 1 plus c, and there's our answer. That's partial fractions right there. What do you think? Okay, so a rational function p of x over q of x is called proper if the degree of p of x denoted the degree of p is less than the degree of q of x. For example, that is a proper fraction. That is not proper, nor is that. So we could use partial fractions to solve this integrand right here. Something like this, we're going to have to do long division first. If the rational function is not proper, you can use, listen to this, long division to rewrite it. Then we can use simple integration techniques. Okay, so now, here we go. Let's see if we can factor that quadratic right there. So I'm going to go proper. Let's see. Let's go, how about an x minus 5 and an x minus 2. There we go. All right. Now, we're going to multiply both sides by this x squared minus 7x plus 10. Or I could write it over here like this now. Let's go the x minus 2 with an a over it, and the x minus 5 with the b over it right there. And let's multiply both sides by that divisor right there. So we have on the left then a1 equals a times the quantity x minus 5 plus b times the quantity x minus 2. All right, now let the a equal a 5 or a 2. Doesn't matter which one you do first. I'm going to do the 2 first here. So I'm going to have what? a1 equals negative 3a. So a equals negative 1/3. Now the x is going to have to equal the 5. So we're going to get a1 equals, and that would be a 3b. So b is 1/3. And now let's set it up. So let's bring out the negative 1/3 out front. And then we've got our, what was our a over there? The x minus 2, so dx over x minus 2. All right, and then bring the b out front, which is the negative 1/3 or positive 1/3. And now we've got our dx over the x minus 5. And now we're almost done. So I have negative 1/3 natural log of the absolute value of x minus 2 plus 1/3 natural log of the absolute value of x minus 5 plus c. That's partial fractions, my friends. Pretty easy, isn't it? All right, let's do a little bit more here. So now, okay, this one's a little uglier, but hey, let's do it. So let's take our first factor and put it under an a, our second factor and put it under a b. How about we take that third factor in that divisor and put it under a c? Okay, and now we're going to multiply everything by the divisor on the left to get x squared plus 2 equals, and then we've got x minus 1's cancel, and I have a times 2x minus 8 times x plus 2. And then the 2x minus 8's cancel to get a b times x minus 1 times x plus 2. And then the x plus 2's cancel to get a c times x minus 1 times 2x minus 8. Right on. Okay, so now let's do this. All right, I don't know which one I'm going to choose first. How about we let x equal 4? Now this time I got to plug that in on the left too, so I'm going to get a 16 and 18 equals, that term's gone. So I have a 3 times a 6, that's an 18, 18b. So if 18 equals 18b, b equals 1. Okay, now let's let x equal a negative 2. So now I've got a 4 plus 2 is a 6. And that's going to equal, well, x plus 2 is gone, x plus 2, I'm right here, and the x was what? Negative 2? What was my x? Yeah, negative 2. So I've got a negative 3, and then a negative 4, negative 8. That's negative, is that positive 36? Yep, so it looks like c is 1 over 6. And now, let's let x equal 1. So if x equals 1, I've got 3 equals, gone, gone, and here I have a negative 6 and a 3, a negative 18, right? So that's going to be negative 1/6. And there you have it. So let's clean this up here. Let's pull the factor of a out, negative 1 over 6. And then I've got a dx over x minus 1. Factor of b out, which is just a 1, so put a plus there. And then we've got a dx over 2x minus 8. All right. And then the factor of c out, which is 1/6. And then what do we have here? We've got the dx over x plus 2. Now let's do each of these. Now, there's two possible answers here. Your textbook uses one method all the time. At the University of Portland, we used another method all the time. So I'll show you both methods. So the first one is pretty obvious. We got a negative 1/6, and then we got the natural log of the absolute value of x minus 1. Now in the second one, at Portland, we'd take the common factor out, which would be 1/2. And then we'd have what? The natural log of, and if I pull the 1/2 out, I have an x minus 4 right there. Okay, and then the 1/6, natural log of absolute value of x plus 2, and then plus c. And that is the correct answer. This is not the answer your book would show. Your book wants you to use substitution instead of pulling out common factors. And I honestly think they do that just to have you practice substitution. So your book's answer is going to be like this. You're going to let u equal 2x minus 8. And then the differential of u would be a 2du. And do your substitution. So you're going to get, well, what do I have here? A 1 over my u. And then my du gives me that extra factor of 2 I'm going to have to undo with a 1/2. And now we work this one out. And we're going to get 1/2 the natural log of u, which is my 2x minus 8, plus c. Now, if I replace this blue term up here with this blue term right here, we're going to get two equations that the difference between them is at the constant c. It's pretty amazing. So that's it. But they are both appropriate answers. So let me show you what I did to show you, and check this out. So I put these both in as y sub 1 and then y sub 2. And then I went graph y sub 1 minus y sub 2. And see that horizontal line? That is y sub 1 minus y sub 2 right there. It's the constant c. It's the only difference between those two answers. Kind of cool. So answers in the back of the book will be substitution. And probably to make things easier on you guys, we'll use substitution more often. Although I'm always a big fan of pulling out coefficients. Okay? So, now, what if p of x over q of x is not proper? That is, if the degree of p is greater than or equal to the degree of q. We use long division. And we're going to go p of x over q of x. Now let's remember our rule for division. Isn't this first term going to be my quotient? And then I have my remainder and my divisor. Now we don't use q of x for quotient here because q of x is our divisor over here. So we got to use something else. So we're going to use a g of x, and then we can go ahead and go r of x for the remainder and d of x for the divisor. Remember though, g of x is our quotient when we do our long division. Where g of x is a polynomial and r of x over q of x is proper. We may then integrate p of x over q of x using partial fraction decomposition of r of x over q of x. So let's do it. Not proper. It's time for some long division, you guys. The degree of p is greater than or equal to the degree of q. Okay, so long division. We're going to take that x squared minus 4 and put it into x cubed plus 1. Just like that. And I know it's been a while, but what are we going to multiply by? X. And that's going to give me an x cubed minus 4x. And then we subtract these polynomials. And if we do that, I've got to go minus a negative 4x, get a 4x, and then plus 1. All right. And I have my divisor, my quotient, and my remainder right there. So I'm going to say the quotient was the x, the divisor was the x squared minus 4, and the remainder was the 4x plus, the divisor, quotient, divisor, remainder. I messed that up. Remainder and divisor. Here's the divisor. The x squared minus 4. Okay. Don't do that. All right. And now let's do this one. So we're going to go the antiderivative of x dx. And then the improper fraction, the antiderivative of 4x plus 1 over x squared minus 4 dx. And let's factor that. Yeah, the degree of p is now less than the degree of q. We're good. I see that. All right. So let's go x plus 2, x minus 2. I'll put an a over one and a b over the other one, and then multiply through by my divisor on the left to get 4x plus 1 equals a times x plus 2 plus b times x minus 2. All right. Now, let's go ahead and pick an x. How about we go x equals, oh, I don't know, negative 2. So I've got negative 8 plus 1 is negative 7 equals, gone, negative 4b. So b is 7 over 4. Okay, let's go x equals positive 2. So that's going to be a 9 equals a times, and positive, that'd be a 4a. So a is 9 over 4. And we're ready to go. So the antiderivative of x cubed plus 1 over x squared minus 4 is going to be, okay, well that would be a 1/2 x squared. And then my first term here is going to be the a, 9 over 4. Okay, and then I'm going to go over here. The dx over x minus 2, or 1 over x minus 2 dx if you want. And then the b is the 7 over 4. And then we've got 1 over x plus 2 dx. And now let's finish this baby. So we've got 1/2 x squared plus 9/4 the natural log of x minus 2. Natural log of the absolute value of x minus 2 plus 7/4 natural log of the absolute value of x plus 2 plus a c. And there's our answer right there. Isn't that cool? And my friends, that's the end of day 1. I hope you enjoyed it. I'll get you a video of day 2 tomorrow.